Hey guys, welcome back. We got another one going on. It's almost noon. My apologies. Next time I'll make sure to upload it before noon. So let's get right into it. We got another motion problem. This one's a no calculator one from the 2007 AP exam. I haven't had a chance to look at the rubric yet, so we'll look at it together in a little bit. So let's go ahead and see what this one's about. It says a particle moves along the x-axis with position at time t given by x of t equals e to the negative t sine t between 0 and 2 pi. All right. Find the time at which the particle is furthest to the left. Justify your answer. All right. Since this is position, I know that velocity has to be the derivative of this guy. And why do I need that? Well, because I need to find out where the velocity changes from negative to positive. Because if velocity is negative, I'm traveling to the left. And if I want furthest left, well, I need to know the transition when I'm going from negative to positive. I hope that makes sense to you guys. Just imagine you're traveling to the left, and then all of a sudden you're you just start moving to the right. So when are you furthest left? Whenever you change from moving left to right. So here we go. We're going to find the velocity. So to do that, we're going to take the derivative, and we're going to do product in combination with chain, but let's see, maybe it's not even chain. It's just product rule, guys. First, e to the negative t times derivative of the second. The derivative of sine is cosine, plus second sine t times derivative of the first. So negative e to the negative t. I went ahead and already put the negative in the front there. If you want to go e to the negative t times negative 1, that's fine. So there it is. I need to find my critical numbers, so I need to equal that to 0. So here is how I look so far. So v of t equals e to the negative t cosine t minus, and I'm going to bring that e to the negative t to the front here, e to the negative t sine t. I still equal that to 0. I'm going to factor out an e to the negative t, guys. E to the negative t. If I factor that out, I'm going to have cosine t minus sine t. Perfect. So you got to have some knowledge about the unit circle. I am literally only looking between 0 and 2 pi. And the only way this will zero out, e to the negative t will never be 0. Will never be 0. And that's just for notes purposes. I wouldn't actually write that on the AP exam. But cosine t minus sine t will be 0. I need to know where cosine and sine have the same magnitude, because I'm going to be taking a number and I'm going to subtract that same number. So where do they both have the same magnitude? Well, it happens twice. It happens at power 4, and it happens at, 5 power 4? So you got to know that. And that just comes from your pre-cal knowledge, guys. It's not even extreme pre-cal, it's just a little bit of pre-cal. You know that at power 4, you're square root of 2 over 2, comma square root of 2 over 2. So there it is. So where does this happen? This happens at pi over 4 and at 5 pi over 4. All right, next, I'm going to... Let's see, what would be the ideal way? I guess the best way now, guys, because I have a closed loop, I think the best way is just to test each one, to make a table. So here we go. Or yes, you can do a number line and see where it goes from negative to positive. But I just think in this situation, we only have 2 points to check plus the endpoint. So it's probably just best just to make a table, guys. T equals an x of t. Because you got to check your endpoints anyways, right? So if you have a closed loop, just go ahead and just make a table all the time. So let's see. I'm going to test 0. I'm going to test pi over 4. I'm going to test 5 pi over 4. And I'm going to test 2 pi. So we're looking for the one that is furthest left. So here we go. X of 0 is just e to the 0, which is just 1. Sine of 0, which is 0. So I get 0. And I guess you can do the same thing with the 2 pi already right off the bat. E of 2 pi is e to the negative 2 pi times sine of 0, which is 0. So that's 0 as well. All right, now let's try these. X of pi over 4. So it's going to be e to the negative pi over 4, which I don't know what that number is. It's just some number that's positive, times sine of pi over 4, which is square root of 2 over 2. So that's what I get there. So e to the negative pi over 4, square root of 2 over 2. If you want to write square root of 2 or e negative pi over 4 square root of 2 all divided by 2, that's the same thing. X to the 5 pi over 4, e to the negative 5 pi over 4. It's just some number, some positive number. But sine of 5 pi over 4 is negative square root of 2 over 2. There we go. We found it, guys. So negative e to the 5 pi over 4 negative square root of 2 over 2. When am I furthest left? At 5 pi over 4. Why? Because it's the only value that is negative. It's the only one. All the other ones are positive. Well, I guess that's not positive. That's 0 and that's 0. But this one's positive. That's a positive value. But this is a negative value. And these are positions, by the way. So I'm furthest left at t equals 5 pi over 4. So I'm going to write the only position value. Should I write the only position value that is negative? The only position value that is negative occurs at t equals 5 pi over 4. Hence, furthest left at t equals 5 pi over 4. Alright, I think that's good enough. I think that will get you the full credit. You probably don't even have to mention that. You could have just said t equals 5 pi over 4 is when you're furthest left. But there it is. We got it, guys. Alright, let's see. Find the value of the constant a for which x of t satisfies the equation a x prime prime of t plus x prime of t plus x of t equals 0. Alright, so let's see. We already know that x of t was e to the negative t sine t. So the first thing you got to do is create this equation and equal it to 0, guys. So let's see. I already have x prime of t. That was what my velocity was. And it is that guy up there. I'll leave it right here so I can see it. E to the negative t cosine t minus sine t. And I need to find the second derivative now. X prime prime of t. So first, I'm going to use that as first, and this is second. So first, e to the negative t times derivative of the second. The derivative of cosine t is the negative sine t. The derivative of sine is cosine t minus cosine t. Plus second, cosine t minus sine t times derivative of the first. Negative e to the negative t. I can see again that both products here have an e to the negative t there. So that's what I'm going to factor out. X prime prime of t equals e to the negative t. And let's see if I can do this. Negative sine t minus cosine t. Now I have a plus here, but notice I have that negative there. If I would have distributed the negative, I would have had a minus cosine t plus sine t. Alright, so what I am seeing is that the sine t's will cancel out, and I'll have two of these. So negative 2, let's see. I'm going to go ahead and multiply, guys, already by e to the t. Negative 2 e to the negative t cosine t. So there it is. Now I'm going to write this. So here we go. A times negative 2e to the negative t cosine t plus e to the negative t cosine t minus sine t, and then finally plus e to the negative t sine t, and all that equals 0. So now it just becomes algebra, guys. And here's what I'm noticing. What am I noticing? I can factor out an e to the t on everything. So let me go ahead and factor that out. E to the negative t, parenthesis. So now I have, let's see, negative 2a cosine t. And then, let's see, I factored that guy out, plus cosine t. Let's see, minus sine t plus sine t. All right, perfect. We're getting somewhere, guys. So I see these sine t's canceling out. And let's see, so now that's all I have. All right, let's factor out a cosine t, guys. E to the negative t cosine t, parenthesis, negative 2a plus 1. Yay, we got it. We got it. Those guys are so tricky. All right, the only way this will be 0, and I know there's a cosine t there, and we can figure out values where cosine t is 0. But we want to find A. That's not the point. That's what we're looking for. We're finding A. See? Find the value of the constant A. So, since we want to find the value of the constant A, we focus our attention on this guy. And remember, we have it equal to 0. So, the only way that equals 0 is if the expression negative 2a plus 1 equals 0. So, negative 2a plus 1 equals 0. Negative 2a equals negative 1. A equals a positive half. And there it is, guys. So, A equals a positive half. That was a little tricky. All right, let's see how they broke it down. So, like I said, I haven't seen the rubric of this one just yet. 2007. So let's look at that one. 2007, OneDrive, Math Life. All right, here we go. So it was a non-calculator one, so it had to be somewhere here. Here it is, guys. So let's see. Letter A was 5 points. Letter B was 4 points. You find the derivative. They gave you 2 points for the correct derivative, and there it is. Perfect. You set the derivative equal to 0, and you find critical numbers. Pi over 4, 5 pi over 4, perfect. And the candidates for the absolute minimum are, and there it is. There's other ways. You could have done a number line. But I feel that this is the best route because you still have to test your endpoints anyways, 0 and 2 pi. So there it is. And they said that equals 0. That's a positive number. That's a negative number. That equals 0. So there it is. And then they just wrote the particles furthest to the left when t equals 5 pi over 4. I like it. I like it, guys. Anytime you have, 1 or 2 critical numbers and closed endpoints, go ahead and do this whenever they want absolute minimum. Let's continue. Because that really is what it is, right? It's an absolute minimum problem. Letter B, they found the second derivative, just like we did. Look, perfect. So we got our 2 points for the second derivative. And then they did what we did. Perfect. And there you go. Yeah, guys. So I think everyone's is gonna look more or less exactly the same because that's what you have to do to get to A equals a half. So you're gonna have to do that algebra, guys. And that's where the algebra might get you. So yeah, I think we did a good job on that one, guys. All right, hopefully you guys are happy, and we'll see you guys later, guys. All right, bye-bye.